You are very welcome to lesson 6, which is about state and life cycle. State makes components dynamic and interactive. Without a state, you cannot change a rendered component. A state is an object that determines how that component renders and behaves. To use state, first of all, you need to convert your function component to class component. Then add local state to the class and change the state by setState method. Let's do that in action. So to remember, to convert a function component to a class component, first of all, we create a ES6 class with the same name that extend React.component. Then add a single empty method to it called render. In third step, move the body of the function into the render method. In fourth step, replace probes with this.probes in the render body. And the fifth step is deleting the remaining empty function declaration. Do you remember the sample we have used in lesson 3, which was about rendering elements? Here we have a class, we have a function component clock, which accepts a probes property and show the current date, current time here. We want to convert it to the class component. Very good. Let's rename this class to lesson 6, which is state. And first of all, we need to define a class clock which extends React.component, and inside class we define a render method like this and copy the body of clock function here. Then add this to the probes and delete the empty function. As you see, we converted a functional component to a class component. You see, it works like a charm. The second step is to use state. To use a state, first of all, we need to define a constructor like this, and inside constructor define the default value of state, which in this sample is date, is new date. Very good. So we do not use the set interval, and we render only one time, and we use set interval in some other place. Let's format the code. Okay. Here, instead of this.probes, we use this.state. As you see, this.state.date to local string. And here we call the super. As you see, we render the current date time, but it doesn't update every second. So since we can change the value of state, we need an interval to change it every second. So let's do that. In the constructor, we can use set interval, and inside this function we can define this dot tick, and here this dot tick. Here we define the tick function, which use this dot set state, and here we want to change date to new date. The point is that the tick function does not have access to this. So here we need to make this accessible inside this function by this command. We bind the this, which is the clock object, to this method, and inside this method we have access to this, so we use setState to change the current date. As you see, we encapsulated the changing time every second inside the clock component. Very good. As you see, the other slides talk about adding state to the class, and here we define the initial value of this dot state, and here we render the clock, and you can remove the probes from clock, and it works because it doesn't need the probes inside the clock, and it depends on the state instead of probes. Then in slide 8 we implemented the tick function, which used this set state to set the new date, and in 9 slide there is an important point, which is about using state correctly. You should not modify state directly. So this command is completely wrong and it doesn't work. Instead of this, you should use setState to change the value of state. Very good. There is another important point, which is about state updating. You should know that state updates may be asynchronous because this dot probes and this dot state may be updated asynchronously. You should not rely on their value for calculating the next step. So using this command is completely wrong because setState depends on the value of a state, which is completely wrong. And to use in such cases, you can use a second form of setState that accepts a function rather than an object. This function receives the previous state as a first argument, and the probes at the time and the probes at that time, the update is applied as a second argument. As you see here, the setState has two arguments, state and probes, and you can use state and probes which are about the previous state. State updates are merged. When you call setState, React merges the object you provide into the current state. For example, your state may contain several independent variables, like an array of posts and arrays of comments. So you can update them independently with separate setState calls. Here inside comment did mount, which I will talk about in next lesson. Inside this method, we use this.setState post. So the comment state will be unchanged. So merging is shallow. So the setState command leave this.state.post intact, but completely replace this.state.comments. Very good. Let's review the data flows down. Neither parent nor child component can know if a certain component is stateful or not. And they shouldn't care whether it's defined as a function or a class. This is why state is often called local or encapsulated. It's not accessible to any component other than the one that owns and set it. A component may choose to pass its state down as a probes to its child component, like in this situation. This also works for user-defined component like this, format date and date. Inside format date will be like a probe. This is commonly called a top-down or unidirectional data flow. So in this lesson, we have talked about state, and in next lesson, we will talk about lifecycle, which is events occur when a component render in the DOM. Thanks for your listening, and bye-bye.